Good morning. We're looking at surface area, which is the total sum of lateral faces and bases. The faces are everything that's vertical, everything standing, and then the base is going to be the top and the bottom. So before we look at this problem, I want to let you know that instead of using the dimensions given to us in the problem, we're going to use like the actual, we're going to use just the formulas, and then we're going to go by, let's see if the side lengths are doubled. So from here, I need to find the original surface area. And the original surface area is where S equals a side. So the surface area of a cube is going to be 6S squared. Now I need to find the new surface area. And our new surface area, like our problem says the side lengths are doubled or twice as long. So that's going to be 2S. So wherever I see the S, I'm going to make that a 2S. So then I'm going to have surface area equals 6 times 2S squared. So I take the 2 exponent and I distribute it into the parentheses. And then from here, I get 6 times 4S squared. And then 6 times 24, or 6 times 4 is 24. So my new surface area is going to be 24S squared. So now I want to do is I want to take the ratio of the new surface area divided by the ratio of the value of the original surface area. So that is going to be 24S squared divided by 6S squared. And then when I simplify, let's see what it looks like when I simplify. When we simplify, we're going to get 4. And so it says the new surface area, the new surface area will be 4 times the old. Hi, we're going to look at this new problem. So it says, look at the rectangular prism. If the width is doubled, then which of the following statements about its volume will be true? So the first thing we need to know is that a volume is a space occupied by a 3D figure. In this case, we have a rectangular prism. So the formula for a volume is pretty simple. It's V equals length times width times height. And again, we're not going to use the dimensions of this prism. We're just going to use the formula length times width times height as our original measurement. So the original volume is going to be length times width times height. And then we're going to take the width and we're going to double it in our new volume. So the new volume, again, says that the width is doubled. So that's going to be 2W. And then when I substitute that into the formula, I get W equals L, open parentheses, 2W, close parentheses, times H. And then I distribute that. So I'm going to get V equals 2LWH. And then I want to take the ratio of the new volume divided by the original volume. So I get 2LWH divided by LWH. And my answer is going to be 2. That means that the new volume will be twice or 2 times the old volume. Parallelogram. If both dimensions are halved, then which of the following statements about its perimeter will be true? We're only using the formula for a perimeter. So the formula for a perimeter, well, first the perimeter is going to be the length around the polygon or around the parallelogram. And the two sides are just A and B. So it's going to be A plus B times 2 when we're looking for the formula of the original perimeter. Again, we're not using the dimensions. We're just using the if statement. So it says if both dimensions are halved. So that's going to be the new perimeter. And that's going to be, again, A and B equals the side. So I'm going to have 1/2 A and 1/2 B because the dimensions are halved. So that means that I'm going to have P equals 2 times 1/2 A plus 1/2 B. So from there, I'm going to distribute my 2 into my parentheses, and I'm going to get 1a plus 1b equals the perimeter. So the new perimeter is going to be a plus b. And then we have to make our ratio. So our ratio is going to be the new perimeter divided by the original perimeter. And then we're going to solve this rational expression. So I'm going to have a plus b in parentheses divided by 2 times a plus b. And when I simplify, I get 1 divided by 2. So your answer for this case means that we're going to have the new perimeter will be 1/2 of the old perimeter. If a cone's radius and slant height are quadrupled, then which of the following statements about its surface area will be true? We're going to have to look up this formula so I know it. So I'm going to draw a cone. The slant height is actually like, it's kind of like the edge of the triangle that's formed on top of the cone. And it's the surface area, so that's what goes around that circumference. That's what's going to surround the circumference and then make that pyramid shape on top, or triangle shape. So R is the radius and S equals slant height. So for the formula of a surface area, you're going to add the slant height and the radius and then multiply by pi times R. Again, so surface area of a cone is pi R times R plus S. And then we go to the new surface area, and it says the cone's radius is going to be multiplied by 4 and the slant height is going to be multiplied by 4, because that's what quadrupled means. So 4 times the radius is 4R and 4 times the slant height is 4S. So all I'm going to do is substitute that 4R and 4S back into the original surface area formula. So I have pi times 4R, open parentheses, 4R plus 4S. I'm going to rearrange some of the coefficients. I'm going to take the 4 out of the R plus S because I want to, this is going to help me simplify. So at the end, I'm going to get 16 pi R times R plus S. And then I'm going to create the ratio, where my ratio is going to be the new surface area divided by the original surface area. And that's going to be 16 pi R times R plus S divided by pi R times R plus S. And then when I eliminate those, I'm going to get the pi's go away, the R's, and then the R plus S is a whole number sentence, so the whole thing goes away. And then I'm left with 16. Now, if we go back and look at and we're going to read our solutions, the only one that says 16 is the ratio of the new surface area to the old surface area will be 16 plus 1.